Hi, my name is Matthew Philson, and I'm working in collaboration with PhD candidate Hoda Parvin and Professor Mark Van Ooyen in the 2009 SURE program. Now, we are working with service centers for firms, and an important distinction to make between service centers and call centers are that service centers, or rather call centers, the actual customer is always in the system, versus where a service center, the customer would drop off their problem and then come back after a set time. Now, this allows the firm to manipulate their system however much they like behind the scenes a lot more, which, because they don't have to deal with the customer becoming upset because they're being put on hold for 5 times or so on and so forth. So, anyways, moving on, some couple characteristics of each of these problems are there will be different levels of difficulty, different types of problems completely. There will be, strict deadlines, and there will be penalty costs associated with violating these deadlines. So here's an illustration of a very, very simple service center. So as you see, there are different job types and different severity levels, with more severe problems having perhaps shorter or longer times. That one varies, but they'll be worth more, cost more if the firm should violate the deadline. Now, as you can see, the different calls come in, and then based on the algorithm for sorting them, they'll go to the different agents, which will finish them one by one. Moving on. So for the actual data, we weren't just picking and choosing random points. We're working with real-world data to find the average service times for these agents. And each agent, as you saw on the previous slide, was trained to handle different types of problems. Say, like, one agent could solve software problems, while other could do hardware and customer relations problems. But so one of the most common methods of sorting these problems when they come to the call center is first come, first serve. However, that is pretty inefficient, so we've developed a new algorithm that would help improve the efficiency of it, that calculates an index for each of the calls based on the cost, the job type, the remaining time until the job expires in the system, with the agents and their skill set, and many more variables. So here are some results from our algorithm. And as you can see, the blue is the first come, first serve type, which in the base case, our index-based algorithm is significantly lower. Next bar over, we improve the skill levels of the agents 30% all around. And while this significantly decreased the average costs incurred for both the first come, first serve and the index was still significantly lower. And for the final bar, we decreased the deadlines, which significantly increased the costs, as expected, for both the first come, first serve and index-based algorithms. But nonetheless, the index-based algorithm was still significantly lower than the first come, first serve algorithm. Another result dealing with different inter-arrival times for the different problems. And as you see, starting out when the problems are close together, as one would expect in service center, there's a huge drastic difference between the first come, first serve algorithm and the index-based algorithm. As we move on, the difference becomes much smaller. Nonetheless, I like to point out that the index-based is still always smaller, have a lower cost than the first come, first serve algorithm. All right, now currently we are adding more functionality to this program, including preemption, which gives the agents the ability to push the call back into the system that they're working on when a more important call comes in. Say that could be either just based on the customer or based on how much it costs. And again, because this is a service center instead of a call center, you wouldn't have any problems dealing with angry customers being put on hold. The critical events we'd also like to add in would be after a certain amount of time before a problem hits its deadline, agents will once again look at the problem and calculate if it's worth dropping their current call to go back and finish this problem on time before going back to their call they were working on before. And also initially we dealt with strict deadlines, with strict costs if a problem should violate this deadline. However, we are considering also adding the ability to not take out a call should it pass its deadline and have a set amount of a cost per unit of time per time that it passes the deadline, just to again make the program more efficient, more flexible, just be able to consider all possible factors in making this program as efficient as possible. And additionally, we like to deal with problems such as since you can't exactly always consider people as computers, there's some variability in there. We'll have to factor that in too eventually. So that is the project I've been working on for this past summer. For prospective SURE students, I highly recommend the program. It has been, it's real-world experience. It's something good to do over the summer instead of just hanging out with your friends or whatever. And so thank you for listening to my presentation, and good luck with your decisions.